Okay, so we're going to still be condensing, but this time a few other things come into play here. So we want to write this expression that we have as one logarithm. Okay, so we check in the front to see if there are any exponents that need to go back up top. Okay, so this one just has an exponent of 1, so that one's fine. But the 1/2 is going to have to come up. So let's rewrite this as log base 2 of x squared. By the way, they're all base 2, right? So that's important. Plus log base 2. And this is going to be x minus 1 to the 1/2 power because we're putting that exponent back up. Now, we're going to fix that in a minute, but for now, we'll just leave it like that. Now, the next part, okay, so is it a 3? Is it a negative 3? I'm going to leave it subtraction, and then my 3 is going to go back up here. But notice there's already an exponent there. Those will have to get multiplied. So it's going to be log base 2. It might help if I write this for you. X plus 3 squared, but then that's being cubed. So those are going to get multiplied. Usually we don't see this, but I think they're just sort of saying, well, what if you had that? Okay, so now I have log 2 of x squared plus, I'm going to write this as log base 2, and I'm going to put this in radical notation. It's going to be the square root of x minus 1. Usually when we have a fraction as an exponent on these logarithm problems, they are going to put it in radical notation. Minus log base 2, and this is now going to be x plus 3 to the 6th power. Okay, and you can put parentheses around that if you want. All right, now we need to condense it to one logarithm. So a little tricky with the exponents. Fraction thing, we're going to make that into a radical, and then that 2 times 3 being 6. Okay, positive ones will go in the numerator. The ones that are being subtracted will go in the denominator. So we'll have x squared times, remember it changes to multiplication now, so addition becomes the multiplication for those arguments, over, it's over because it's subtraction here, x plus 3 to the 6th power. So it's going to be written like that. Kind of squeezed it in there. So that was fun, a little bit different. This one's even more different. There's a typo in the book on this one. So I'm going to do this problem the way it's written. And it's written in the original problem in the text like this. But there's an error. Okay, so first of all, we're trying to do the same thing, condense it. The 2 will go back up. That's not a problem. The 4 will go back up. That's not a problem. Now what are we going to do with that 1 over x? We're going to write that as x to the negative 1. Okay? So now I have log, and these are all common logs, x squared minus log x plus 5 to the 4th power, and then it's going to be plus log 3x plus 5 to the negative, or sorry, to the x minus 1. We can put that in some brackets or something. Now, here's where their error comes in. This is addition, and order of operations doesn't say you add first, and that's what they did in the book. So I'm going to follow the order of operations. Negative ones are going to go in the denominator. Positive addition, those arguments are going to go in the numerator. So log, and it's going to be x squared 3x plus 5 to the negative x power, which is kind of different right there. And I wrote it wrong. See, talk about errors. Okay, x to the negative 1 power. And then that's going to be over x plus 5 to the 4th. Okay, so that's how I'm going to write it. And yeah, you'll see it in the book if you want to look. All right.